This video is about topic 5.2, exercise 53, which talks about trig functions in the unit circle, finding cosine when given sine. Remember, when dealing with these types of questions, our quadrant is very important. Exercise 53 states, if sine of angle t is equal to negative 1 over 4, and t is in the third quadrant, find the cosine of angle t. First, let's go over the Pythagorean theorem as well as our basic trig ratios. Here on this triangle, we have leg A, leg B, and hypotenuse C. Remember, our Pythagorean theorem states that the length of leg A squared plus the length of leg B squared is equal to the length of our hypotenuse squared. Our basic trig ratios are SO, CA, and TOA. This is the acronym we use to memorize it. So sine of theta is equal to our opposite over our hypotenuse. Our cosine of theta is equal to our adjacent over our hypotenuse. And our tangent of theta is equal to our opposite over our adjacent. These essentially refer to the length of the sides of the triangle in respect to the angle. So if we come over here to this triangle once again, the opposite is the side across from our angle. So the opposite side of theta is B, and our hypotenuse is right over here, which connects the two legs. Our adjacent side is the one directly next to our angle. So in this case, our adjacent side would be leg A. Let's also go over the unit circle right here because we're going to talk about the importance of our quadrant. So let's sketch our unit circle over here. So we have quadrant 1, quadrant 2, quadrant 3, and 4. We're in this quadrant down over here. So let me just sketch our triangle just for a quick reminder. This is not going to be accurate to the question because on the unit circle, if we're on any point on the unit circle, so as long as we're on the unit circle, the distance from that point to the origin over here is equal to 1. And in this case, if we look at our sine of angle t is equal to negative 1 over 4, our hypotenuse is not equal to 1. But I'm just sketching this in order to get the direction of our sides. So here we see that sine of angle t is equal to negative 1 over 4. So the opposite over the hypotenuse. So the opposite side of angle t is going to be over here, which is negative 1. And our hypotenuse is down over here. So we know the opposite and the hypotenuse side, but we do not know the adjacent side. So I'm going to sketch this triangle down over here. And before we solve for the adjacent side, let's talk about, again, the importance of the quadrant. When we are in quadrant 3, both our cosine of theta and our sine of theta are less than 0. You can clearly see that because, again, our sine is negative here. And remember that your hypotenuse, no matter what, will always be positive. So now we can solve for the adjacent side using the Pythagorean theorem, which I'll write down over here. So the length of our opposite side, which is our leg, is going to be negative 1 squared, plus the adjacent side squared is equal to the length of our hypotenuse squared. You can write this as negative 1 squared is equal to 1, plus adjacent side squared is equal to 4 squared, which is 16. Now we can subtract 1 from each side, and we will get that our adjacent squared is equal to 15. We can take the square root of both sides. You can write plus or minus, remember. And then if we write down here, we will get that our adjacent side is equal to plus or minus square root of 15. Remember, t is in the third quadrant, and as we covered earlier, since our cosine of theta must be negative and our hypotenuse is always positive, that must mean that our adjacent must be negative. So the length of our adjacent side is equal to negative square root of 15. Let me write that down over here. So a reminder that negative square root of 15 is not our answer because, again, we're not finding the length of the adjacent side. We are going to find a cosine of angle t. And our cosine of angle t is going to be the length of our adjacent over hypotenuse. Since we solved for the length of our adjacent side and we know the length of our hypotenuse, you can just write it out with the ratio. Our adjacent side, negative square root of 15, over the length of our hypotenuse, which is 4. So in total, the cosine of angle t is equal to negative square root of 15 over 4. Remember, our quadrant determines whether this is positive or negative, and if you envision the unit circle or even draw it out like I did over here, you'll be able to find out that whether your adjacent or your opposite side will be equal to a negative value or a positive value.